Okay, now these are slightly difficult examples at your stage. Look at NaClO, it's a compound. We know that overall oxidation number is what? 0. Now, group 1 sodium must be +1. Assign group 1 first. Now these are two non-metals, chlorine and oxygen. Now which to assign first? Both are non-metals. For metals it is easy. If it is metal, we know metal is plus and non-metal is minus anyway. But two non-metals are competing, then the one which is more electronegative, must be assigned the negative charge first. Okay, and we can have a very simple rule for their more electronegativity, that is this thing. If you remember this word, a sort of Poncel, mean En value increases like this. So if fluorine and oxygen are competing, or they are taken together, fluorine must be negative and oxygen must be positive. Nitrogen or oxygen are competing, oxygen must be negative, or nitrogen, chlorine are competing, or whatever. I mean, these are the most electronegative. And you know, in groups, electronegativity decreases. Group 5, group 6, group 7, electronegativity decreases down the group. Group 5 like nitrogen, phosphorus, arsenic, antimony, bismuth decreases. Or group 6, oxygen, sulfur, selenium, tellurium, polonium decreases downward. Group 7, fluorine, chlorine, bromine, iodine decreases downward. So you can place oxidation number accordingly, but most common, 99% time you'll find out, you'll come across these, and you'll have this rule in the mind, FONCl, okay? F is the most electronegative. According to that rule, I need to assign oxygen first, because oxygen is more electronegative. So oxygen will enjoy its valency, -2. Overall it is 0, it means chlorine must be +1. So this is the case where oxidation number varies than that of the genuine valency it has. Okay, so this compound can have a systematic name, and systematic name depends on the element whose oxidation number has changed. Like this is, we can call it as sodium chlorate and 1. We write sodium chlorate 1 because oxidation number of chlorine is not genuine. Genuine should be -1. It is +1 here. And check out this sodium chlorate. Overall oxidation number is 0. Now sodium is again first to assign. Out of these two, I said oxidation number should be given to the oxygen first because electronegativity is more. -2 into how many they are? 3 makes it as -6. To make it 0, simple mathematical procedure, it is -6 here, it's +1 there. It means we need to place +5 at chlorine. Chlorine is having a +5 oxidation number. Okay, so it means out of ordinary it is, and the compound's name goes as sodium chlorate 5, the systematic name. Easy to place oxidation numbers if you follow the rules. Look at FeO, overall oxidation number is 0. And since transition element has come into the game, we don't know what it is, but we know that oxygen group 6 -2, it should be +2. So you will find mostly written as iron 2 oxide. This Roman 2 stands for iron's oxidation number. And if it is Fe2O3, overall oxidation number is 0. Iron, transition element, we don't know, but we know this, oxygen -2 into 3 -6, so it means it is +6. But when it is +6, oxidation number of iron is not +6, it should be +3 because there are two iron atoms. Look at this, more interesting, NO overall is 0. We don't know the oxidation numbers directly unless we follow the rule. And what rule is? Oxygen is more electronegative. It will have its oxidation number from the valency. And nitrogen is +2. Although normally you know that nitrogen is -3. But when it competes with oxygen, it somehow fall in oxidation number. Check here. Again, it is overall oxidation number 0. Oxygen must be given the respect more electronegative, -2 into 2 what? -4. And nitrogen is +4 here. Overall again 0. It is -2 into 3 -6. Nitrogen is then what? +6. -2 into 3 because there are 3 atoms. Overall -6, that should be +6. It means systematic names changes like because the nitrogen is undergoing a change, out of ordinary, out of usual, because nitrogen belongs to group 5 and group 5 should have an ideal oxidation number of -3. But in this case you find out it is varying, so it should be nitrogen 2 oxide here. And if the oxidation number goes to +4, it should be +4 here, 4 oxide. And if it is +6, it should be 6 here, nitrogen 6 oxide. This is how the systematic name changes. Okay, to get this SO2 you will place 0. Now both are the non-metals. It's not metal and a non-metal that you place metal positive and non-metal negative. Oxygen O2, it is in the elite panel of more electronegative, rather most electronegative element in the periodic table. Sulfur is not even in the game. So oxygen is -2 into 2 -4. Oxygen is given the importance because of the fact that it stays in the electronegative value panel. Okay, then sulfur is +4 here. Okay, check here, overall is 0, and oxygen should be given the importance because of the EN status it enjoys. It is -6, sulfur is what? +6. Okay, so we can place the oxidation number accordingly. Neutral compounds, but this is the polyatomic ion SO4. You normally in your GCO levels or GCSE memorize their oxidation numbers, overall oxidation numbers, overall charges, overall charge. Sulfate ion it is taken as polyatomic ion, it's a radical. Okay, so overall oxidation number for it is -2. And we want to find out, again we'll see oxygen is more electronegative, -2 into 4 makes it as -8. To make it -2, it's -8 here, sulfur must be what? +6, because +6 and -8 makes it as what? -2. Okay, so look at this nitrate ion, again it's a polyatomic ion, -1 it is the oxidation, overall oxidation number. So oxygen is given the importance because of the fact of electronegativity, more electronegative, it is -6. To make it -1, it should be +5. Same goes for carbonate ion, you place it as overall 2 -2. And oxygen is given the importance because carbon is not in the scene of electronegativity. -2 into 3, -6. I said -2 because it belongs to group 6. So it will enforce its oxidation number, being more electronegative. And carbon goes to what? It is -6, -2 there, it means carbon should be +4. +4 and -6, the answer is -2. Same goes for ammonium ion. Okay, you can practice ammonium ion, overall oxidation number is what? +1. And out of these two, the importance goes to what? Hydrogen belong to group 1. +1 into 4. +4. If it is +4 and answer is +1 of the overall charge, it should be then what? -3. -3 plus 4 makes +1. So these were some of comparatively difficult examples. We'll take more. एक last set of